Hello everyone, this is the first lesson recording for IM1 January 8th, 2021. We started off by just thinking about this problem, okay? Since it's a Happy New Year and beginning of 2021, perhaps it's a time to discuss allowance plan with your parents. Well, actually, I am not suggesting that you do, but this is just a hypothetical situation. Which one would you rather have? Okay, if you were able to get allowance, would you rather get $10 each day from your parents every day for a whole year? Okay, so you're receiving $10 each day. Or would you like to start with $1 and have your parents double the amount they give you each month? That means in January you get $1, in February you get $2, and in March you get $4, and so on. Okay, how much would you, which one would you rather have for the for 1 year? Okay, so I want you to pause the video and see if you can think about it. And it's just a fun exercise. Okay, and we'll discuss this in a little while. Okay, so what are we doing today? We are studying a new unit, Unit 4, and that's CPM Chapter 5. It's called Sequences, and Chapter 6, System of Equations. So Unit 4 is going to contain both the sequences and the system of equations. So let's go back to our 2021 allowance plan. So if I was to receive $10 each day, since there are 365 days in a year, I am getting $10 each day, so I am going to earn $3,650 from my parents, or I'm going to receive $3,650 from my parents. But what about the other plan? Okay, do you think the other plan is better? It certainly does not sound like it, but let's have a look. If I start with $1 and doubling each month, then if I could form a table, so in January I received $1, in February I received $2, in March $4, $8, $16, all the way, and by December I am receiving $2,048. Look at that. Look how much the numbers are increasing. That's pretty amazing, isn't it? Okay, so does that mean that it's far better to receive the first option because $3,650 seem like a bigger number than $2,048? Well, think about the problem again. Okay, this is how much you're going to be receiving each month. So if I actually total how much I am receiving from my parents by the end of the year. So by January, at the end of January, I have received $1. At the end of February, I have received $3. That's because 1 plus 2 is 3. And then in March, I received $4 more, so therefore get $7 altogether. In April 15, and so on. If I add all of them up, by the end of the year, by December 31st, I would have received $4,095. And so which is a greater amount that I'm going to receive from my parents? It is actually the second option. So that's just kind of a fun exercise. Okay, now that we've talked about it, okay, if I was to just make a list of how much I am receiving from my parents, the list will look like this: 10, 20, 30, 40, 50, 60, so on, all the way to $3,650. Okay, so that would be one list. And if I was to think about how much I am receiving from my parents each month, this will be another list. But if I was to think about how much I have already received by the end of each month, this will be the third list. Okay, so when you have a list of numbers with certain rule or certain pattern, we call that sequence. And so these, the blue numbers, the purple numbers, and the pink numbers, they're all examples of sequences. So keep that in mind, and let's explore sequences. So you are going to be doing the card number 1 and 2 of the Desmos exercise. So please pause the video and complete those two now. The first card is just a temperature check, just to see how are you feeling today. Okay, how are you doing overall? So you can move this dot according to how you feel. It says this is when you're not doing so well. Red is you're not doing so well. And look, you see the happy face. This means you're doing great. Okay, so move the dot to where you are feeling. Then what number comes next? Okay, given that sequence is just a pattern of numbers or list of numbers with a specific rule, what do you think comes next? Okay, you don't have to get it all right, but see if you can come up with some answers. Okay, for the next card, you're looking at the sequence of numbers and see if you can fill in the rest. Okay, if there is a looking at this number, list of numbers, do you see a pattern here? 1, 3, 5, 7. What do you think comes next? Hopefully you are saying it's 9 and 11. Okay, because it seems like going up in odd numbers. Okay, so then what about the next one? 2, 4, 8, and 16. Well, do you see a pattern here? 2 and 4, the difference is 2, but the difference between 4 and 8 is 4, and the difference between 8 and 16 is 8. Do you see some other pattern? It looks like it's being doubled. 2 becomes 4, 4 doubled is 8, 8 doubled is 16, and 16 doubled will be 32, and then 32 doubled will be 64. Okay, and let's keep scrolling down. All right, what about this? 20, 17, 14, and 11. Okay, now this time the numbers are going down. Okay, how are they going down? They're going down by 3 each time. 20 becomes 17. 17 take away 3 is 14. 14 take away 3 is 11. So we just need to take 3 away from here, and that leaves me with 8. 8 take away 3 will be 5. So this will be my list. Now this time 1, 4, 9, 16. This is a little bit more tricky and some of you might have hard time seeing what the pattern is. But looking at this, 1, 4, 9, 16. Do you notice those numbers at all? And we just talked about a whole lot of it last lesson. They're perfect squares, aren't they? Okay, it's 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 4 squared is 16. So now we are looking for 5 squared here, which is 25. What's 6 squared? That's 36. Okay, so this is a list of perfect square numbers. So going back to our slide, sequence is just a list of numbers with some rule to generate the numbers. Okay, so if you have the sequence here, 1, 3, 5, 7, 9, 10, 9, 11, that was the first sequence. What do you think was the rule? What do you think was the rule that got the next number? You added 2 to the previous number. Okay, what about the second list? 2, 4, 8, 16, 32, 64. What was the rule? We said it was doubling or you're multiplying previous number by 2. That's basically what doubling is. What about the third one? The numbers went down this time and it went down by 3. So in this case, you are subtracting 3 to the previous number. Or you can also think of it as adding -3 to the previous number. Okay, we prefer to think in terms of addition because we can always deal with a negative or subtracting by adding its opposite or adding its negative. The last one was 1, 4, 9, 16, 25, 36, and that was the perfect square or squaring the position. Okay, this was the first number. This was the second number. So 2 squared is 4 and so on. Squaring the position of the number. Okay, so those were the rules. All right, then sequence can be written as a list of numbers like -4, -1, 2, 5, 8, 11, and 14, like that, where each number in the sequence is called a term. So -4, oh, okay, and we use the notation n to denote, to represent the term number, and t of n, or sometimes we use a of n as well, which is the value of the nth term. Okay, so sometimes I use, different textbooks would use different notation. Some textbooks would use t of n, or some would use lowercase a of n. And you can read this as t sub n or a of n. All right, so then from the list, the first term is the first number on the list. So -4 is the first term, or we will represent it as t of 1 or a of 1. Or -1 is the second term, you will represent it as t of 2 or a of 2 or a sub 2. And this will be the third term, t of 3. And then you can continue like this. And this is the 1, 2, 3, 4, 5, 6, 7th on the list. So we would say this is the seventh term, or t of 7 is how we would use the notation, okay, to refer to this number. 14 is the value, and to refer to it, to name it, we would use t of 7. So these are the notation. And sequence can also be represented as a table of values. Okay, so where n represents the position, like this is a first, second number, third number, fourth number, and so on. And t of n represents the value. Okay, so the list can be represented as a table right here. -4, 1, 2, 5, 8, -4, 1, 2, 5, 8, so on. And the same sequence can also be represented as a graph like so, where the x-axis is represented by n, the term number, and the y-axis is represented by the value of each term. Okay, so the input will be n and the output will be the value of each term. All right, so then let's go on to Desmos card number 3 to 6. Pause the video and try doing those now. It's number 3 to 6, not 4 to 6. Okay, so card number 3 is card sort, okay, where you are matching different cards. When you see 4, 11, 18, and 25, what do you think is the row? So you're matching the row with the list. Okay, so you have 100, 96, 92, 88. You have 4, 12, 36. Okay, so let's just put them up there so that we can see what we're dealing with. Okay, so all right, so one of the rule is okay, divide the previous number by 2. What do you think? If you're dividing by 2, is the number going, are the numbers going to go up or down? You're dividing, so numbers going to get smaller. Okay, and it's going to get smaller, so you're dividing the previous number, like 40 becomes 20, 20 becomes 10, and so on. So these two match up, so I'm going to put them together. All right, multiply the previous number term by 3. Which is the previous term? This is the previous term. Multiplied by 3. 4 times 3 will be 12. This is not it. 100 times 3 will be 300. This is not it. 4 times 3 will be 12. Then 12 times 3 will be 36, and 36 times 3 will be 108. So this one matches with this. And then subtract 4 from the previous term. So if I subtract 4 from the previous term, you'll get 96, 92, 88. So I can match these two. Add 7 to the previous term. That would match with this. And then finally multiply the previous term by 2 would match with this. Okay, that's it. And then card number 4 gives you feedback on how well you did, whether you got all of them correct. I will continue in the next lesson recording.